Health monitors test the availability of devices and services on their network and are used to determine whether pool members are working properly. Monitors generally test specific devices for an expected response within a defined time interval. Monitors tell the LTM if a server is available or not. Monitors allow BIG-IP to test servers and attempt to ensure client traffic is not sent to a pool member that is not serving good content. Generally, BIG-IP initiates traffic from its non-floating self-IP address to the server, performs its test, and then terminates the connection. Both active and standby systems monitor servers. In the case of the inbound monitor, BIG-IP observes client interactions with the server to determine the server's monitor status. From the simple, is an address reachable, to the complex, is the application behaving properly? Simplest test, is the IP address reachable? Good points, it's simple. Bad points, can mark pool members down that are working fine. For example, if a router or a firewall will not allow ICMP to the nodes, the ICMP monitor will fail and mark the nodes and pool members down even though TCP traffic might be working just fine. Service checks only test whether the service is listening on a port. The TCP monitor opens a TCP connection to the specified IP address and port and then closes the connection. The monitor is successful if the TCP connection is established. Content checks are the first level of viable tests in many situations. Is the server listening, and is it responding with good content? Monitors can also interact with multiple servers, sending multiple commands and processing multiple responses. Most interactive checks are external monitors. The LTM calls an external script using shell, Perl, etc. that performs one or more tests and aggregates the results. For example, the FTP monitor logs in, changes to a specified directory, and then requests a specific file. Path checks are only viable if the router or firewall to be tested is local to the BIG-IP. The monitor packet will be sent with a MAC address of the pool member and an IP address defined as the alias in the monitor definition. The alias should be a trusted device on the other side of the pool member. Path or transparent monitors are the primary reason for allowing multiple monitors to be assigned to it, not requiring all of them to be working. If only one trusted site were to be tested and it failed, all routers and firewalls would be marked down. By testing two or more trusted sites and indicating that at least one monitor will work, as long as one of the trusted sites are functioning, the monitor will be effective. Most templates are just that, templates. They are not designed to be used in production. For example, many sites use the HTTP monitor in production, but that would not generally be recommended. HTTP opens a connection, sends GET, and then marks the device up regardless of the response. Without a user-defined receive rule, the HTTP monitor will fail to detect many server problems. ICMP is one of the few exceptions. Unless you wish to change the timers, there is no reason to create a custom ICMP monitor. The options in the configuration section vary significantly depending on what type of monitor chosen. A monitor example, HTTP. Send string is a command sent to the server. The default is listed here in the send string. Receive string is what content should be found to mark device up. Default is null. This area is actually empty until you put something in it. Receive disable string. If content is found, it marks the device as disabled. requires receiver string to be specified also. The reverse receive rule. If content is found, it marks the device as down. The transparent rule. If the path is available, the device is up. Designed to monitor links and should also have an alias address set. If we were to change the configuration to advanced, you would see a screen like this. We have the up interval, frequency of testing when server is available, time until up, wait time after successful, monitor before marking server up. Manual resume. If monitor marks device unavailable and then available, it leaves the device as disabled state, requiring manual resume. Alias address is down here at the bottom. It's an optional hard-coded destination IP address for the monitor. And the alias port is the optional hard-coded destination port for the monitor. There are two types of monitor timers: frequency, how often the monitor is initiated, and timeout, how long before the device is marked unavailable if there is no success. There are 4 ways to add monitors. Assign to all nodes. It is the most common, but the least effective. Assign to individual nodes. This is rare. Assign to a pool and all members of the pool. This is most common as well. Assign to an individual pool member. This is rare. We will do this in an upcoming lab. To assign a monitor, click the node list, select the node, select the health monitors, and then apply the changes. We will also do this in an upcoming lab. Select your pool, then select your monitor, and then apply your changes. And once again, we will also do this in an upcoming lab. Status options. These are really important to memorize. You'll see these a lot and wonder, is this pool up or is it down? Or why is it up or why is it down? Memorizing these colors and what they mean will help you successfully troubleshoot in the future. Node status, based on its monitor only. Member status, combination of node status and member monitor. Node status cannot result in a member being available, but can result in a member being offline. Pool status, a single available member makes the pool available. If some are offline and others are unknown, the pool will be unknown. Virtual server status, if the default pool is available, the virtual server will be available. If the virtual server is only associated with an iRule, at least one of the pools must be available for the virtual server to be available. If one pool is offline and all else is unknown, the virtual server will be offline. In order to see visually what is happening on the BIG-IP, there is a set of general BIG-IP and module-specific dashboard gauges that can be viewed as part of the performance dashboard. Some of the module-specific dashboards include LTM, GTM, WOM. The performance dashboard provides near real-time statistics as well as historical and performance statistics. The dashboard also provides graphs, gauges, and tables on the health of various TMOS objects and alert notifications. The performance dashboard can be accessed through the Statistics tab. This is what the performance dashboard looks like. We can monitor any performance effects our changes can have on the system. Some changes will cause the CPU to spike. Others will have no effect. In these labs, we will create custom monitors and assign these custom monitors to our pools, our virtual servers, and our nodes.